This is the second video, the companion video for functional groups and naming and organic chemistry. So let's start off with carboxylic acids. Again, I'm following your flashcards, so if you want to look at those, you can see what I'm drawing this information from. So the general formula for carboxylic acids is you'd have a carbon double bonded to an oxygen that is then bonded to a hydroxide, which is also bonded to the rest of the chain. So this would be on the end of a carbon chain, the hydroxide and the double bonded O. You have an alcohol basically right here. There's the alcohol, and then you have the thing right here, this double bonded oxygen, which we just learned would be considered an aldehyde. So it's like an aldehyde that has been oxidized, basically. Okay, so anyway, these guys, their names end with oic. They end with oic. They end with oic. Oic acid, actually, to be accurate. Oic acid. So you could be given this drawing and asked to name it. So this one, you'd figure out what's the long chain. So we've got 2 carbons, so we know that the base of this name is going to be the 2 carbon prefix, which is eth. It'll be ethan, actually. And then we see that there is a hydroxide on the end, and the carbon that hydroxide is bonded to also has an oxygen double bonded to it. It's got both of those. So that would make this ethanoic acid. Okay, now why don't you try to draw pentanoic acid? Pentanoic acid. Pent. Well, I know that it would have 5 carbons. 3, 4, 5. 5 carbons. It's a carboxylic acid because it has the ending oic acid. That means this last carbon had better have a hydroxide on it, and it better also have a double bonded oxygen. Make sure all your carbons have 4 bonds. Your oxygens should only have 2 bonds. If you are asked to draw valence electrons, then, and you would never be wrong to draw them. So if you end up skipping off those or leaving off those valence electrons, you better be sure that they're okay with it. So that would be pentanoic. 1, 2, 3, 4, 5 hydroxide and double bonded O. So that's a carboxylic acid. Okay, what about esters? Esters have the general formula of a carbon, also double bonded to an oxygen, which then has another oxygen, but that oxygen is then bonded to the rest of another chain. And here we just have the chain going off both ends. So esters are not on the edge of the chain. They could be anywhere in the middle. And their names end in 8. They end with 8. So for instance, let's draw this one. We could have 1, 2, 3, oxygen, and then we could have this. So, and then these guys all have, those are all hydrogens on there. So in order to name these, you have to figure out, okay, what part of it is attached to the double bonded O and what part of it is not. The first part of the name it's two words. The first part of the name is going to be this section that is not connected to the double bonded O. This section only has two carbons, so this is an ethyl group. This other group here, this other section that is double bonded to the O, has three carbons, so we know it's going to have propan something. So the name for it would actually be, how would we write this? It would be ethyl propanoate. Ethyl propan. I know the example, the naming example of here is just 8, but you almost always have an O added in there too. Ethyl propanoate. So the group that is not double bonded to the O comes first in the name, and then the group that is double bonded to the O comes second in the name. So let's try that again. Why don't you draw methyl ethanoate? Methyl ethanoate. Ethanoate. Let's draw that. So I know the section that is double bonded to the O is the ethanoate section, so that means I have this 2-carbon chain that is attached to the oxygen. I then have this oxygen that is stranded in the middle, and it needs to have a methyl group attached to it. So that's only one hydrogen or one carbon. This is methyl because you have a single carbon, and here is the ethanoate section. That is an ester. You have an oxygen in the middle, and the carbon directly next to it is double bonded to another oxygen. Okay, that's esters. Now, whoops. Okay, let's do amines. Amines and amides, they both revolve around nitrogen. Nitrogen is the key element here. So its general formula is going to be a nitrogen that is bonded to a hydrogen, and then the rest of the chain. And actually, those hydrogens could all be replaced with groups. They do not have to be hydrogens. I could have N, R, R, R. I could have N, R, R, H. All of these would be considered amines, but generally that's the one that we use for like the general formula. And their names will either contain amino or what we will use more often is they will end in amine. End in amine. Now these guys can get crazy complicated. We're just going to stick with the super simple ones. You guys know amino acids? Probably learned about them in biology. Yeah, they get crazy names. Okay, so let's draw one. Let's label one. How about let's draw this one. Okay. So one thing you want to remember is nitrogens are only going to form 3 bonds. And if you needed to draw the valence electrons, you'd need to show that it's got these here as well. Okay, let's name this. So first you figure out the group that you have, so it's only one carbon, which is a methyl group. Then you tag amine on the end because it's got a nitrogen. And that's it, methylamine. Okay, let's try drawing. What should we draw? How about ethylamine? Try it without me. Hopefully you paused and tried it out. So ethylamine will have 2 carbons bonded to a nitrogen, which then has its hydrogens. Carbon forms 4 bonds, so let's draw those on there. 1, 2, 3, hydrogens, hydrogens, hydrogens. And if I was going to include valence electrons, I'd need to show, oh, this nitrogen has valence electrons on it. If I wanted to draw this more accurately, those hydrogens would probably be pushed up away from that electron pair. Okay, so there are amines. Last one, amides. So these guys are similar. You would have a carbon, but this time that carbon is double bonded to an oxygen and nitrogen. It's not double bonded to the nitrogen, but the nitrogen is there. So, and then you have the chain. And again, this does not have to be on the end. You could have a carbon double bonded to an oxygen with a nitrogen that has a hydrogen, but then also goes on to the rest of the group. So these nitrogens can be in the center, and this hydrogen up here, that could be another carbon too. The key is that we've got a nitrogen that is bonded to a carbon that is double bonded to an oxygen. That's the key. And this one, it's the name, or these names, they end in amide. Let's just say that. End in amide. So these names aren't super complicated. You just need to know if it's an amine or an amide. So let's draw, what should we draw? Let's draw this one. Let's see. Carbon has 4 bonds, so that one's done. There. Okay. So in order to name this, you need to figure out what is the name of the base chain. I see 2 carbons, so my prefix will be eth, and it's actually going to be ethane, like ethane. So take off that E, it becomes ethanamide. Ethanamide. Okay, now you try drawing let's do propanamide. 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 You should have tried this without me. Hopefully you paused. We know prop means 3 carbons. And then, oops, that's not right. I know that this last carbon needs to be bonded to a nitrogen, which would then have its hydrogens attached to it. And here we have oxygen. There. So I won't ask you to name an amide that has a carbon chain that continues on after the nitrogen. However, I might ask you what functional group can be found inside of this molecule, and you'd have to say, oh look, there's a nitrogen that's bonded to a carbon that's double bonded to an oxygen. This has an amide within it. I don't know the exact name, but I know there's an amide in it. Okay, so now that you have watched these videos, I've gone over all of the, I believe all of the concepts that are hard to learn on your own. What you need to do now is get those flashcards from Canvas, print them out, cut them up, and use them. Learn different concepts. You need to learn what isomers are. You need to figure out well, just understand what a cyclo something is, know what benzene is. Get those worksheets out and practice. You should have everything you need now to be able to master the organic chemistry section. Good luck.